All right, guys, your essential question is, how do we apply the first derivative test to find relative extrema and intervals of increasing and decreasing behavior? Now, guys, we're actually going to split this up between two sections, and we're only going to be looking at intervals of increasing and decreasing behavior. How do we tell when a function is increasing and when a function is decreasing? Now, the first derivative test will mainly be in the second half of this lesson, but let's go over some notes right quick. Many of the applications of calculus depend on our ability to deduce facts about a function and information concerning its derivatives. I hate to say this, but when in doubt, take the derivative because you can do something with it. Now, since the derivative of f represents the slopes of the tangent lines, the derivative is able to tell us what the function is doing. For example, if the graph is increasing, the slope of the tangent line will be positive. So basically, if the derivative is positive, that means the function is increasing. If the slope is negative, that means the graph is decreasing. All right, but let's lay down some basic definitions of just simply when is a function increasing and when is a function decreasing. The definition of strictly increasing is a function is strictly increasing on an interval I if f of x of 1 is less than f of x of 2 whenever x of 1 is less than x of 2. In other words, the second value of the y is greater than the previous value of the y. And then also a function is strictly decreasing if the f of x1 value is greater than the f of x2 value. In other words, if the previous value is more than the next value, then obviously the graph is decreasing. Okay, so notice then that this graph is increasing up until B, then after B it's decreasing to C, and then it's increasing again up to D. So that would be the increasing and decreasing behavior of the function. Now, how does the derivative connect with increasing and decreasing functions? Well, when the function is increasing, the sign of the slope of the tangent line is positive. So in other words, when the derivative is positive, that lets me know the function is increasing. On the flip side of that is, how do I tell when a function is decreasing? The slope of the tangent line is negative. And then that tells me that the function is decreasing. So in other words, I know that the slope of this tangent line is positive here because the graph is increasing. The slope of the tangent line, or the derivative, is negative here because it's decreasing, and then the derivative here is increasing. The derivative is positive because the function is increasing. So that's how the derivative is connected to telling whether or not a function is increasing or decreasing. Now, the test for increasing and decreasing functions is let f be differentiable on an interval ab if the derivative is greater than 0. In other words, if it's positive, then the function is increasing. If the derivative is negative or less than 0, then the function is decreasing on that interval. Finally, if the derivative is 0 on that interval, then that means that f is constant. It's staying the same number over that interval. Okay? Now, here's your procedures for finding the intervals on which a function is increasing or decreasing. Let f be a continuous function on an open interval ab. To find the open intervals on which f is increasing or decreasing, the first thing you got to do is find those critical numbers. So find where the derivative is 0 or undefined. Okay, very crucial. Once you find those critical numbers, we're going to make a sign chart. Okay, basically the sign chart consists of the critical numbers and any x values that make the derivative undefined. Okay, we're going to test the sign between those critical numbers of the derivative. Okay, so basically what you're going to do is you're going to pick a number to test, you're going to plug that into the derivative, and whatever the sign is, either plus or minus, that'll tell you if it's increasing or decreasing. Because remember, if the derivative value is greater than 0, so positive, then it's increasing. If the derivative value is negative, it is decreasing. All right, and then you're going to draw your conclusions about the intervals of increasing and decreasing from that sign chart. Okay? All right, so that's what we're going to be doing for the examples for today.